There we go. 7-6 Dilations. The book lesson is actually called Lesson 7-6 Similarity Transformations. So your homework assignment on Schoology is called this, just so you know. Same thing though. Okay, so it starts out with vocabulary of like the bigger picture, and then it narrows down to what we're actually doing today. A transformation, which you may remember from 8th grade, is when you change a figure by sliding it, which is called a translation. There's a whole chapter on transformations though, so this bigger picture we'll get to later, but this is just an overview. Sliding, you could flip a figure like a reflection, turn a figure, or enlarge or reduce it. What we're focusing on today is the enlarge and reduce, which is called dilation. These two words right here, pre-image and image. Pre-image is the original figure. It's the figure you're starting out with. And then image is the new figure after the transformation. So the resulting image after performing a transformation. Another thing that is important is this prime notation. Here it shows the pre-image, the first image, and then they slide it here to get the image. What happens to the points is you have A, which is your original, and then A prime, which is after the transformation. So there's this little, like one right here, a dash, and that means A prime, B prime, and C prime. Okay, dilation, this is what we're focusing on today. A dilation is a transformation that produces an image that is the same shape as the original, but it is a different size. So you're like stretching or shrinking the shape. What does this have to do with similarity? Well, when you stretch it or shrink it, they're going to be similar shapes. It's going to be similar to the original. And this here, another definition for dilation is a similarity transformation. And it enlarges or reduces a figure proportionally. Okay, what else? Scale factor. Scale factor, we're going to continue to use the variable k. The scale factor is the ratio of the image to the pre-image. That order is important, image to pre-image. So when you set up the ratio for scale factor, it's the image over the pre-image or the new figure over the original. And then we have enlargement and reduction. So I mentioned a dilation, it can make the figure either larger or smaller. If the figure gets larger, it's called an enlargement, so figure gets larger. When a figure gets larger, the scale factor is greater than 1. So for example, k could equal 2, or k could equal 3.5. It's like how many times larger that figure is getting. And then reduction, as you may predict, is when a figure gets smaller. When you have a reduction, k is less than 1. It's also greater than 0. So k would be in between 0 and 1. So for example, k might be 1/2, like it's half the size of the original. K might be 0.3. We're not turning the page yet. We're going to do a little example right here. Okay, so here it shows two images. This is the pre-image A, and this is the image B. So we're going from A to B. So we're going this way. This would be the pre-image, and this would be the image. So when, I forgot that the battery is dying. Hold on. Plug it in. So going from A to B, you can see that B is a little bit larger than A. So it's getting larger. It's called an enlargement. And then we need the scale factor, K. K is, and then we have it right here, the image over the pre-image. So we'll choose a corresponding side like this and this. These are corresponding sides. It's our image over a pre-image, so 8 over 4. 8 divided by 4 is 2, so K equals 2. And that's the gist. So turn to the next page. We're going to do some practice just like that. Okay, number 1. It says, and these are just like the homework problems you'll see, determine whether the dilation from A to B is an enlargement or a reduction. Then find the scale factor of the dilation. So from A to B, here A is our larger figure, B is smaller. So to go from a larger to a smaller is called a reduction. And then what you need to do is find a corresponding side so that way you can find the scale factor. So I'm just going to choose this side compared to this one. So the length of this side is 1, 2, 3, 4, 5, 6 units. And the length of this side here is definitely 2, and then it looks like a half on each side, so it's 3. Usually they go right to the corner. It's just odd that they would do that, but oh well. Then we need to do the image over the pre-image. So the second one over the first, so it'll be K equals 3 over 6. Then reduce that to 1/2, K equals 1/2. And then just make sure that's logical. If it's a reduction, K has to be less than 1, and 1/2 is less than 1. Number 2. So from A to B this time, we have a smaller, we're going to a larger figure, so it is an enlargement. Pick a set of corresponding sides, maybe this side to this one. 1, 2, 3, 4. 4 units there, and 3 units here. So you're doing the image over the pre-image, so 4 over 3. K equals 4 over 3. You would reduce this if you could, but we can't, that's it. And K has to be larger than 1, and 4 divided by 3 is more than 1, so we're good. And the third one. So going from A to B, B is smaller, so it is a reduction. Choose 2 corresponding sides. I'm going to choose this side and this one here. 1, 2, 3. This is 6 units and 3 units here. So K would be 3 over 6, which simplifies to 1/2. So K equals 1/2. Okay, number 4. It says graph the original figure and its dilated image, then verify that the dilation is a similarity transformation. So we're going to graph these two. If they're similar, their side lengths will be proportional based on like a scale factor. So we're going to start by graphing the pre-image. I'll use pencil for the pre-image. It is at A is 2, 3, so we'll just plot these points. There's the pre-image, and then the image. I'm going to plot this in blue. Okay, so there's our images, our pre-image and our image. We can see that they're about the same shape. We just need to make sure that they are related through a scale factor. We would need to find the side lengths of each of these. Now, we can use this Pythagorean theorem, but then we just get really weird numbers. So I'm going to give you the numbers here. If you were to use Pythagorean theorem to find the side length here, we would get square root of 8 and square root of 32. So those corresponding sides, square root of 8 and square root of 32. Then over here, the length of this is square root of 40 and square root of 10. If these came out to whole numbers, we'd be doing the work for it, but it just doesn't. With these square roots, square root of 8 times 4 is square root of 32, square root of 10 times 4 is square root of 40, and then this here is square root of 10 and square root of 40 as well. So since we can multiply by 4 to get the dimensions of the other triangle, then yes, it is a similarity transformation. And you won't have to do that on your own for the homework or anything, just so that you're aware of how to do it. Okay, next, 2 examples. Now it gets easier again. Find the image of each polygon with the given vertices after a dilation centered at the origin with a given scale factor. Okay, so they give us the points of the pre-image, so I'm going to go ahead and plot those points. Q is at 0, 6. We have Q. This is our pre-image. It tells us the scale factor is 1/3. So we need each of these side lengths to be 1/3 of the actual side length. It seems like a lot of work, but there's actually a shortcut. What we're going to do is take each of these coordinates and multiply it by 1/3. And since this is centered at the origin, that will give us the new shape that is 1/3 the size of the original. So I'm going to take point Q and call it Q prime. And then multiply the coordinates by 1/3. 0 times 1/3 is just 0. 6 times 1/3, or 6 divided by 3, is 2. So Q prime is 0, 2. Then R prime, I'm doing the same thing. -6 times 1/3 would be -2. -3 times 1/3 is -1. And S prime, 6 times 1/3 is 2. -3 times 1/3 is -1. And now I'm going to plot these new points. That's it. That's our new. Okay, the next one. Plotting the original points. 2, 1 is point A, B, C, and D. Makes this weird like trapezoid type shape. Then it tells us that our scale factor is 2, so we need each of these side lengths to get greater, like 2 times greater. We're going to take the coordinates again and just multiply everything by 2. So A prime will be 2 times 2 is 4, 1 times 2 is 2. B prime, 0 times 2 is just 0, and 3 times 2 is 6. C prime, -2 and 4. And D prime is 0, 2. and then I'll plot the new points. That's it. And there's your image. And that's it. The homework will probably be pretty easy for you. The homework looks like this, so definitely keep this out as a reference. If you finish the homework early, which I'm sure you will, make sure to complete another 1 or 2 Khan Academy assignments. If you're stuck on Khan Academy, just raise your hand or ask somebody around you if they can help you with it. And that's it. So go ahead and get a computer.